3.3a, variable on both sides. If there is a variable on both sides of an equation, we use the addition or subtraction principle to get all of the variables on one side. Doesn't matter which side, either side, whichever is easier. Then we use the other principles to solve the equation. So let's go through a couple of examples. Let's jump right into it. Example 1. Solve 3x plus 1 equals 4x minus 12 for x. So, first of all, we want to get all of the variables on one side. So let's use the subtraction principle to get this 3x over on this right-hand side. So we have to subtract by 3x on both sides. So what happens? 3x minus 3x is just 0, and 4x minus 3x is just x. And we bring down everything else. It's good practice to write the next step in the equation right below so that you can follow an equation as you go along. So if you were to ever look back on your work, you could immediately see which step you did every line you go down the page. So from here, we can see that we have to employ the addition principle to get x by itself. We have to add 12 to both sides. Once we do that, we have 13 equals x. And that's our solution. Now we could have gone the other way and subtracted 4x from both sides. That's totally valid. We would have just had a negative x on this left-hand side and had to use the multiplication principle, so it would be one extra step. But it's totally fine. That's the thing about solving these algebraic equations. You can go and solve them in multiple ways and still get the same answer. So let's try it. Let's see if we would have subtracted by 4x. So we have 3x plus 1 equals 4x minus 12. If we would have subtracted 4x in the beginning from both sides, the 4x's cancel on the right-hand side, and we're left with negative x plus 1 equals negative 12. From here, we use the subtraction principle to cancel out the 1 and get the x term by itself. So we have negative x equals 12. Negative 12 minus 1 is negative 13. Now we use the multiplication principle and multiply both sides by negative 1, and we get x equals 13. So here we went in a totally different way but got the same solution. It is fine to do this. Let's solve another equation. Solve negative x plus 4 equals x plus 12 for x. So I'm going to just add x to both sides to start off with. I'm going to use the addition principle, mostly because I don't like negative variables. I think it's prettier to have positive variables. So let's just add x to both sides. Why add x? So that these will cancel here, and I bring down the 4 and the 12 like normal. So negative 4 equals 2x plus 12. It's 2x because x plus x equals 2x. Now I subtract 12 from both sides using the subtraction principle to get the x term by itself. So 12 minus 12 cancel, and negative 16 is on this left-hand side and 2x is on the right-hand side, and I divide both sides by 2 using the division principle. These operations cancel. Negative 16 divided by 2 is negative 8, and I'm left with x equals negative 8.